Okay, so what we want to do in this question here is we want to find the radian value of the angle of this particular situation. So we have a terminal arm of an angle in standard position, and it passes through a particular point, and that point is negative 4, 3. So just as a recap to what that implies, going back to this whole idea, when we have a terminal arm here, this is the terminal side, when it's bound through the origin, and there's my initial arm, so it's creating this angle theta, if you will. Okay. Now you already have an idea where we're sending that, where that angle is going to be, or what quad that's going to go into, because we know that the x value here is negative and the y value is positive. So a good idea is to draw that, and when we draw that, we draw our angle theta here, and there's our negative 4. That's the x value, negative 4, and the y value, 3. Now, I just happen to know that that's a 3, 4, 5 triangle from Pythagorean theorem, but that's just me adding some additional information here. Now, now that I know where it is, I know that it's in quad 2. I'm going to go get the angle, but I'm going to get the angle as if it were in quad 1. And the reason I'm going to do that is because I don't always trust my calculator, and I don't always think it's going to send me in the appropriate quad. As you know, we're trying to find the angle between the intervals 0 and 2 pi. And sometimes if you're not very careful, and you blindly put negative values in there, it may send you into, say, quad 4 with a negative angle, or it could actually give you a quad 2 answer, because 10, as you know, will be negative in both quad 4 and quad 2. So just as a rule of thumb, this is me personally, I always assume my values are all positive, and I go find them in quad 1. And when I do that, I get approximately 0.64 radians. Now I know that answer is wrong. I know that this is in quad 2. And now what I'm going to do is I'm just going to correct for the proper placement. And I say, well, I know that to send an angle in quad 1 into quad 2 just requires me to say that pi minus that angle, 0.64, the quad 1 angle, is going to give me this 2.50, which is in quad 2.